Going to solve the fourth problem of the final exam of electricity and magnetism that says like this. An alpha particle with a charge of 2e and a mass of 4u, that the u is the unit of the atomic mass, with an equal of 1.66 times 10 to the minus 27, is traveling in circles of radius, the radius here, 0.45 centimeters, in a region where there is a constant magnetic field of 1.2 Tesla. First we have to find the speed, then we have to find the period, then we have to find the kinetic energy in EV, that here says that 1 EV is equal to 1.6 times 10 to the minus 19 joules, and then we have to find the potential difference to which it should be accelerated so as to resist such kinetic energy. So first we have to use this formula, that the force is equal to the mass times the velocity squared over the radius, because it's circular movement, okay? And this, we know that it's equal to the magnitude of the charge times the velocity itself times the magnetic field. Once we know this, we want to determine the velocity itself. So if we get the velocity out of the equation, we will obtain that the velocity is equal to the magnitude of the charge times the magnetic field times the radius divided by the mass. Once we establish this, we know all the values, so we have to substitute them. We know that the charge is equal to 2 times E. We know that the magnetic field is 1.2 Tesla, and we know that the radius is 4.5 centimeters, but we have to turn them into meters, so we write them like that. And we know that the mass is equal to 4 times 1.6 to the minus 10 to the minus 27. So that is equal to 6.64 times 10 to the minus 27 kilograms. Once we have this, we only put it in the calculator, and we will obtain that the velocity is equal to 2.6 times to the 6 times 10 to the 6 meters over second. That this is equal to 2,600 kilometers over second. Okay. So then, for the next letter, we are asked to find the period. For the period, we have to consider that the velocity is equal to the angular velocity times the radius, and we know that the period is equal to 2 times pi over the same angular velocity. But we know, using this equality here, that 2 pi times the radius is equal, it's divided by the velocity is the same as the period. Once we determine this, we only have to substitute. We know 2 pi, we know the radius, but we turn it into meters in here, and we did use this value in meters, 2.6 times to the 10 to the 6 meters over centimeter. And we will obtain that the period is equal to 1.087 times 10 to the minus 7 centimeters, that is equal to 108.7 nanocentimeters. Okay, this is the result for part B. Now for part C, we are asked to obtain the difference, to obtain the kinetic energy. To obtain the kinetic energy, we know that the kinetic energy is equal, here, the kinetic energy is equal to half the half of the mass we have here, 6.64 times 10 to the minus 27 times we have to multiply it by the velocity itself, 2.6 times 10 to the 6 meters over second, and right there, and by that we obtain the kinetic energy in joules, that is equal to 2.24 times 10 to the minus 14 joules. And that is the kinetic energy. And then for the letter D, we're asked to obtain the potential difference, to which it should be accelerated to as to reach such kinetic energy. And for that, we want the velocity for resisting that potential energy that is equal to the kinetic energy. And for that, we only have to divide the kinetic energy by the charge itself. So the kinetic energy, 2.24 times 10 to the minus 14 joules, divided by the charge that, here I'm missing a step, sorry. Here we are obtaining this in joules, but we have to turn it into EVs because we are asked for that in the problem. So here 2.24 times 10 to the minus 14 joules. We know that 1 EV is equal to 1.6 to the 10 times 10 to the 19 to the minus 19 joules. And once we cancel the joules, we are left with EVs units is equal to 140 times 25 kilo EVs. Okay, and that is the result for that kinetic energy. Then, for obtaining the difference in the potential difference, now we can use this formula, the one that I was giving, and then we use this one, divided by 2E, that is our charge, and this will be equal to 70 kilovolts, and that is the difference in the potential. And that's how you solve this problem.